Hey everyone, today's note is on the application of derivatives. In math, we use basic problem-solving rules. The first is to understand the problem. Figure out what the unknowns are, possibly draw some diagrams, write the information down that we know and that we're missing so that we can, number two, think of a plan. Find any patterns that may exist, think of some analogies perhaps related to a question that we've already done, and sometimes even work backwards. Three, once we've thought of our plan, we want to make sure that we carry out the plan. And number four, a very often forgotten step is to check your work. For the purpose of today's lesson, we're going to be talking about an object's movement. We often think that objects move in a straight line. In math, when describing an object's distance from the origin for a specific time, we call this the displacement or position function. And it's represented by s of t. Velocity is the rate of change of displacement. V of t is equal to s primed of t, or the first derivative of displacement. Acceleration is the rate of change of velocity. A of t is the derivative of v of t, also known as the second derivative of s of t. Now, some keywords that you'll want to remember. Initial means that time is 0. The origin means that s of t is 0, meaning that displacement is 0. Stationary means v of t is 0, means that velocity is nothing. And lastly, constant velocity, a of t is 0, means acceleration is 0. Now, if I was to summarize what we were talking about in terms of 0, or the origin as the case may be, in displacement, if s of t is greater than 0, then our object, or the position of this object, is positive, or to the right of the origin. If s of t is less than 0, it is negative, or to the left of the origin. If s of t is equal to 0, the object is at the origin. Velocity talks about the direction and where the change of direction occurs. If v of t is greater than 0, then the object is moving to the right. If v of t is less than 0, it is moving to the left. If v of t is equal to 0, we already know that that's called stationary. Acceleration looks at objects increasing or decreasing in speed. So, if a of t is greater than 0, then the object is accelerating. If a of t is less than 0, then the object is decelerating. And if a of t is equal to 0, then that's called a constant velocity. It's neither accelerating nor decelerating. Let's try some examples. Some common you've already seen before, and others get a little bit more challenging. A ball is thrown from the upper observation deck of the CN Tower. The distance of the ball in meters above the ground after t seconds is given by the following equation. This equation gives h of t instead of s of t. It doesn't matter. It's the same thing. We're still talking about displacement of this object, which in this case is a ball. From what height is the ball thrown? Meaning at the beginning, at the initial time. So I know that t is 0. So I want to find the height at 0, which is 450 plus 10 times 0 minus 5 times 0 squared, which is 450 meters. What is the initial velocity at which the ball is thrown? The initial velocity means that I want to find v of 0. That's what I want. First of all, I need to find v of t, which means I need to take the derivative of h of t, which is 10 minus 10t. I then want to find v of 0, which is 10 minus 10 times 0, which is 10 meters per second. In case you haven't noticed already, I'm including units in all my answers. We are talking about something that has a unit, which means we must include that unit. It says, what is the velocity of the ball after 5 seconds? Well, that's v at 5. Simply sub in 5 into the equation that you have, which is minus 40 meters per second. Now this makes sense because the object is being thrown down off the observation deck, so of course the velocity will be negative. It's going down. Determine the maximum height reached by the ball. Now when you were in grade 10 or 11, you probably would have completed the square, found the maximum height, and that would have been the end of the question. However, now that we're in calculus, let's think about it a different way. A ball is thrown, which means that it follows a parabolic shape. At the top of that shape, for the brief moment that it hits the maximum, that ball is stopped. So at the maximum height, v of t is equal to 0. I know v of t. v of t is 10 minus 10t is equal to 0. So 10t is 0. So t is equal to 1 second. So I know that this ball reaches its maximum height after 1 second, but I still don't know what the maximum height is. But I can find that by putting 1 into height. That's 450 plus 10 times 1 minus 5 times 1 squared, which is 455 meters. I know that this ball reaches its maximum height at 455 meters 1 second after it's thrown. Now, next question says, determine when and with what velocity the ball hits the ground. If it hits the ground, I know that h at t is equal to 0. So I take my initial equation, minus 5t squared plus 10t plus 450 is equal to 0. I'm going to take out a common factor of negative 5. That's t squared minus 2t minus 90 is equal to 0. I want two things that multiply to negative 90 but add to negative 2. There are no two numbers that do that. So I want to use the quadratic formula. When I use the quadratic formula, as you should right now, pause the video, fill it out, and off you get, and come back, and you should have 10.54 as an answer. So I know that it hits the ground at 10.54 seconds. But I want to know the velocity at which it hit the ground. So I want to know v at 10.54, which is 10 minus 10 times 10.54, which is negative 95.4 meters per second. Fantastic. Not too difficult a question, but notice that this question I could have done in, for example, grade 10 or 11. Now I'm doing it in grade 12, but I'm using calculus in order to answer the question. All right, let's try something a little bit more, not challenging per se, but a little bit more involved because I'm now involving some fractions and maybe some notation that I haven't seen before. This next question talks about the position function of a person on a bicycle pedaling down the street or a steep hill. With increasing effort, it gives me the equation for the displacement of this person on a bike. Here it is. Notice I've thrown in some fractions on purpose, where s is measured in meters and t is in seconds, and t is an element of square bracket 0, 4, square bracket. What the heck does this mean? Well, this means that my time interval is 0 is less than or equal to time, which is less than or equal to 4. Square brackets means equal to. It encloses that term. If it was a round bracket, for example, if I said 0, 3 like this, that would be 0 less than t less than 3. There's no equal to. If, for example, I had said 0 with a square bracket and 5 with a round bracket, it would say this: 0 is less than or equal to t less than 5. It's simply another notation, another way of saying the same thing. It's a really good way and a shorter way of saying it, so I recommend that you get used to it. The question here asks for you to find the velocity and acceleration as functions of time, meaning all it's saying is find the velocity function and find the acceleration function. So find v of t. V of t is 3 over 6, which is a half t squared, plus 2 over 2, which is 1t plus 1. A of t is equal to 2 over 2, which is 1t plus 1. Part B says find the acceleration at 2 seconds, which means find a at 2, which is 2 plus 1, which is 3 meters per second squared. There are the units for acceleration.